let's take a look at Leetcode 123, best time to buy and sell stock 3, and then if you can, so I'm going to show you how to do this in a general way so that you can also knock out best time to buy and sell stock 4. So it's the exact same code, so I'm not going to actually show you how to, I'm not actually going to go through 4, but just know the difference between these two problems is that part 3, you can only use up to 2 transactions. That means you can only buy and sell twice, and then for this part 4 you can buy and sell k times, so there's no difference in the code. So let me just show you how to do it in a very simple way using recursive DFS plus memo. I will say a disclaimer, it's not the fastest method, but I think this is the most intuitive, easy to understand, and you'll never have any issues with time limit exceeded or anything. This works perfectly fine. Yeah, so let's take a look at how to do this. So first of all, we're given the prices of the stock at each given day, and then so they're telling us that we must. So if we have zero shares of the stock, we can't sell anything. So we can't go into the negatives for a number of shares. So we can't short the stock or anything. We have to own the stock in order to sell it. So basically, the way we'll enforce that is basically we'll have a variable called holding. So if this is set to false, that means we're not holding anything. We don't have any shares of it. If it's true, then we will have shares of it. So this is a very classic take or don't take type of DP problem. That means it's kind of like knapsack, kind of like 0 or 1. We either include it or we don't include it. And so you can kind of see that this is pretty much just like a DFS where we explore all the options. I wouldn't necessarily call it backtracking because we're not going back and like rescinding something we did earlier, but it is kind of like DFS because we're exploring all the different options. And if you saw my previous 2 videos, student attendance record 2 and also can't remember the other one. The previous 2 videos that I did were DP, and I used a recursive DFS plus memo as well, so you should have a pretty good idea how to do this after watching those 2 videos. So we'll just keep track of 3 variables. We'll keep track of the index, we'll keep track of the transactions we have left, which starts at 2 always, right, because it says we have 2 at most, and then we'll also have a holding variable which keeps track of whether or not we own a stock. So at each stage, at each turn, at each index, we can either do nothing or we can make a transaction, right? So here we started out at the 0th index. We have 2 possible transactions remaining, and we don't hold anything. We're not holding any stock. Going to the left is doing nothing, right? Because we still don't own anything. And going to the right, we will buy something. And so here you can see that I marked holding as true, right? So the 1 means that they are we're on index 1, and the 2 means that we have 2 transactions left. So this transactions left won't decrement until we actually sell it. So if we buy something that's not considered a transaction, you won't decrement the transactions until you've sold the stock. So you must have bought and sold the stock to be considered a full transaction. So it's pretty straightforward. You really just go down the line, go down index by index, and just try both options each time, right? So also, for going to the right, which is making a transaction, you have to make the correct corresponding transaction depending on whether you're holding or not. If your holding is false, that means you don't own any stock, right? So you can only buy. If your holding is true, then that means you own the stock and you have to sell it, right? It says you can't engage in multiple transactions immediately. You can't buy 5 in a row and then sell all 5 the same. You can only buy 1, sell 1, buy 1, sell 1. So yeah, so your transaction, so if you don't do anything, that's pretty straightforward. If you do decide to make a transaction, it'll be determined by whether or not you're holding a stock or not. So yeah, so it's as straightforward as that. Pretty much you'll just you'll have a base case where if you reach the end of the array, then obviously you should stop iterating. If you if your transactions have gone down to 0, then obviously you should break out. And at the end of each recursive iteration, each recursive call, you'll just return which option was better, right? You'll return the max of these two options. Was doing nothing better or was making a transaction better? So that's kind of what you'll be returning at each intermediate recursive call. And let me kind of show you the code. Try not to memorize it. Try to reason through it. And yeah, so basically we have a backtrack method here, function here, and this is where we're calling it. So we're going to just return the answer to backtrack, right? So like I said, the starting condition is we're starting on index 0, we have 2 transactions left, and we're not holding anything. And then we come into the backtrack, and then these are the 2 base conditions. If our index is equal to the length, then we should obviously stop. And if the k is down to 0, that means we have 0 transactions left, so we should also return 0. And yeah, so pretty much this line right here is doing nothing, right? Because our k value doesn't change, and our holding true or false doesn't change either. So then here, this is the condition. These are the conditions where I do decide to make a transaction. And like I said earlier, the transaction you make is dependent on whether or not you're holding a stock or not. If you are holding something, then you can only sell, right? So this is the logic for selling. So if we're selling, then obviously we'll get some money back, right? So we'll add the money at the current index as well as return the best result from this backtrack. I guess I should call it DFS, but whatever, I'll change that. And then else, so if we're not holding, then we have to buy. So buying will put us in the negatives for the price, right? Because we have to pay money to buy this stock. So we're going to do negative prices plus the answer of this DP right here. And then at the end of each recursive call, we'll just return which was the better option, the max of either doing nothing or doing something. And you can see that I've used memorization here. So this is essentially the same thing as, this could be the same thing as me putting cash equals default dict int, and then having cash of index k holding equals max of do something whatever, return cash of index k holding, right? And then you just have the if index k holding in cash, return cash of index k holding. Yep, so these two are the exact same, right? So we can just see how that does. Might be pretty slow. Yeah, so the cache is even more powerful. You can do this. It's pretty optimized in Python, and it allows you to get rid of those conditions right here. You don't have to actually check for it manually. It'll do that for you. So let's take a look at if we use the cache, the built-in functools cache. Should be pretty good. Alright, so you can apply the exact same logic to part 4, right? Because we can just, instead of 2, we can pass in the whatever k value they give us, right? They pass in a k to us, so we can just pass in the k instead of the 2. And that is it. Hope you guys enjoyed. Hope you guys learned something. Give me feedback, and thanks for watching.